Alright, before we jump into an arithmetic series, I'm going to go ahead and kind of explain the different parts of sigma. So the first thing you're going to see is on the bottom here, k. This is your variable. Your variable here would need to be the same in your equation. If they're not the same, you can't assume that it's just not written right. You need to make sure they're the same letter. Right here, this number is the number you start with. This number up here is your ending number. It's also your n. So in terms of equations, because we're going to have equations that does summations for us. Now, this is sigma. I always think in terms of sum because they both start with s, and the math operator for sum is plus. That means we're going to have to add. Now, what we're going to do is we're going to count by natural numbers. We start at 1, and we're going to start at 1, and we're going to end at 5. And the way we're going to do this is we're going to plug 1 into this equation. We're going to do 2 times 1 plus 1 plus, now after 1's done, we're going to go to 2. So we're going to do 2 times 2 plus 1 plus 2's done, so we need to go to 3. 2 times 3 plus 1. Next is 4. 2 times 4 plus 1. And last but not least is 5, because we're going to finish with 5 because that's the number on our top. It becomes 2 times 5 plus 1. Now this is, if I ask you to do it written out, long form, not using any equations, this is what I'm looking for. The equations I'm going to give you, for all practical purposes, I want you to only use them when it's 1. Sometimes I'll give you a problem where k will start with 3. At that point, you just want to write it out like this. I won't make you do like 50 of them. It'll only be like 2 or 3 of them. But I want to see that you can write this out. From here, it just becomes arithmetic. 2 times 1 is 2, plus 1 makes 3, plus 5, plus 7, plus 9, plus 11. Now when we add these, 3 and 7 makes 10, 9 and 11 makes 20. Wow. So 20 and 10 makes 30. We add 5 to it, and it'll be 35. So this is what the answer would actually be for this equation there. It is important to understand what the different parts of this sigma is. This part right here, I forgot to tell you, this is going to be your nth term equation, which on the last video I was showing you how to find when you use the formula a sub n equals a sub 1 plus n minus 1 times d. Now there are some formulas on the green sheet where you can actually look at there's 2 different formulas where you can look at them and determine which one can you use. And this comes in really handy if you have to find it to a much larger number. Alright, so here's another sigma problem. This time I'm going to start at 1, but I'm going to end at 60. And clearly I'm not going to write this out by hand. I'm not going to do this 60 times. So I'm going to use a different formula. The first thing we have to figure out is which formula. We have 2 formulas we can choose from. We have a formula that says s sub n equals n divided by 2, a sub 1 plus a sub n. Or the other formula is s sub n equals n divided by 2. And on this one, it gives us 2a sub 1 plus n minus 1 d. Now, we can find d pretty easily, but I'm going to choose to use the first one. And simply because I know the number for the first term I need to find and the second term. I know my n is going to be 60. I know my a sub 1 is going to be 2 times 1 plus 1, which will be 3. And my a sub 60, my last term, would be 2 times 60 plus 1, which is 121. So I'm going to use this formula right here. My n is 60, so I'm just going to plug it in. I'm going to do 60 divided by 2 times 3 plus 121, which is my a sub 60. From here, I can simply just basic math, 60 divided by 2. This becomes 124. From here, I know 2 goes into 124 62 times. And when you do 60 times 62, you will get 3,720. So this would be the answer to this sigma. Now we could have used the other one because my d in this case would be 2. But sometimes it's not flat out easy to see what your d is. So if you could calculate your first and last term pretty easily, I would use the first one. But with our d being 2, we could have used this equation. Still calculate your a sub 1, you know your n, pop in your d, and you would still get the same number.